Hello everyone, I am Marit Shamim, and together with Love Hilani and Claude, we are the team behind CleanShield, safeguarding glaciers from black carbon threats. We have come together to tackle one of the most under-monitored threats to glacial health, that is black carbon pollution. In a world, glacier melt is no longer a distant warning. It's a reality. Rivers are drying up, farmers are uncertain when to plant, and downstream communities are losing access to water. Yet, black carbon, one of the key drivers of this melt, is not being tracked where it matters the most. So that is where the CleanShield comes in. CleanShield is a low-cost, solar-powered IoT system that detects black carbon in real time and sends alerts directly to communities at risk. What makes it special is its simplicity and adaptability. It doesn't need constant internet, it doesn't depend on urban labs, and it works where most systems fail, remote glacial zones. From a technical perspective, our system uses an ESP32 microcontroller, which acts as a CPU, which collects data from sensors like MQ135 for air quality or any carbon sensor to collect the deposits of carbon on the surface of glacier, and DHT22 for temperature and humidity. The data is transmitted via XP or LoRa modules, allowing long-range, low-power communications without internet. It's powered entirely by solar energy, making it fully off-grid and sustainable. Here's a circuit diagram showing the construction of CleanShield. In terms of innovation, CleanShield takes what used to be expensive lab-based monitoring and puts it in the hands of local youth and farmers. It's modular, replicable, and costs under $50 per unit. From a feasibility standpoint, we have designed CleanShield to be easily integrated into existing community structures, from local schools to climate action hubs with dashboards and mobile alerts that are multilingual and accessible. And the impact, yes, early warnings, better irrigation planning, and stronger community resilience. CleanShield does not just collect data, it empowers action. Thank you so much.
So, as we were saying, that even though detection is fine, but then the detection isn't enough, people need to understand the threat in real time. So that's why we here at CleanShield, we have our own mobile app. The mobile app displays live air quality using easy-to-read colors, green, amber or yellow, and red to color code. And it supports local languages. So the colors, if it's red, it's a very high risk zone. If it's amber or yellow, it's very moderate. But then if it's green, it's a very low risk area. And also the dashboard comes with taking a real life weather conditions. So here in the app, this is the link for the dashboard. I'm sure it's going to play. Let me share that soon. We'll need to share it. Share here. Okay. Share the streamlet here. So here, this is the live dashboard that we give to companies to actually see. So it comes from real life data. Right now, it's using an API, my local API here that I created from OpenWeather. So with that, it's able to take the current temperature readings. So as you can see, it's 17.1 degrees. The glacier melt risk is low. The black carbon reading is also low. Here it just gives you the black carbon reading for the past maybe couple of days, but then it gives you from mid-June. And also it also shows you the areas that is very high have a high glacier melt risk, and also gives you the time that alert was given out to the companies. So as you can see here, the dashboard works clearly, and it can also, some of the data can be stored via the cloud. My colleague will explain more about the AI model, and it will also help NGOs, climate agencies, and local governments to actually visualize the risk and see what is happening. And for the consumers, it can be in an app. So the app is in our PowerPoint here. This is how it will look like in the phone.
So this is our CleanShield dashboard. So we use AI and machine learning to predict melt risk analysis. So this is our configuration panel. So you can use correlated data, or you upload a CSV file, or you just provide the URL to it. So let me just go on with our correlated data we are using here. So in our dashboard, you start with the problem, then how to use the app. It shows you our data overview. So our model, then you have to train the model. You start by training the model. So it will take some time to train. So model trained successfully. So it gives you the mean square value, the R score, the R square score, and the data visualization. We have a correlation map that shows the temperature, the different relation map. They have Merrick's distribution. We have temperature versus Merrick's box plot of our key values. And then we have also advanced visualization that simulate Merrick's trend over time. And then we have pair plots. So my main focus is the Merrick's assessment and mitigation. So we have the different Merrick's prediction. So you can adjust all these variables to have the predicted value you want. So based on this, our predicted Merrick's, based on the correct values I have here, our predicted Merrick's is at 21.73%, which is low. So this ratio is less than 50%, which is low. So it gives you what to do, maintain, on when vigilant. So we also have a recommended action plan on what to do. So we can generate action plans here. So you can generate an action plan here. So you generate an action plan and set predicted Merrick's is at this value. So this the action plan you can take. At the end of the day, you have the option to download it as download the action plan as a PDF or a Word document. So if I click on Word, yeah, it's going to basically download as a Word and it's going to save it.